Hi friends, now we are going to discuss work energy theorem. This is useful for all 11th grade students, whether it is CBSE or ICSE or IGCSE A level or AS level, or even for IB students also. What is this work energy theorem? Which shows the relationship between the work and kinetic energy. Of course, how it shows. When you have done work by applying a force on an object, it produces change in its kinetic energy. Let us see how it is. Take up. Suppose a body of mass m moving with velocity u is acted upon a force F for a time t. So let V be the final velocity after displacement of an object S. Now we know that here third equation of motion to find the acceleration. So with the help of third equation of motion, what I am going to do, let us see. V square minus u square equal to 2as. Just I'm multiplying both sides with the m by 2. Okay. So when I'm multiplying with the both side m by 2, I have half m v square minus half m u square equal to m a s I got. Whereas MAS gives us, MA is stands for the force and S is a displacement. We know that from the work definition, work equal to product of force and displacement, I can write W equal to half mv square minus half mu square. That is also I can write half mv square gives us final kinetic energy and half mu square gives us initial kinetic energy. That is equal to work done. Now, you can see the change in kinetic energy of a body is equal to the work done on it by the net force. The change in kinetic energy of a body is equal to the work done on it by the net force, remember. The above equation can also be generalized for three-dimensionally for the different vector cases. Now we are seeing v square minus u square equal to s that can be written as in a form of vectors, acceleration and displacement both are vector nature. Since they are in the vector nature, product of two vectors here v dot v square, u dot u square I can write out. Now in the same manner, here also if I multiplying with respect to m by 2, then I have the same equation as previously we got. Therefore, change in its kinetic energy gives us work done. Vectorially also, I'll get same thing here. So this is the work energy theorem. This work energy theorem, now we are going to discuss with the variable force. Till now we were discussed with the constant force. With the variable force, how work energy theorem works out. Look at that. Kinetic energy is given by an object is half mv square, we know. Now, variable force in the sense I'm going to differentiate with respect to time this. Okay, we know differentiation, we studied the basic formulas of differentiation. So that is dk by dt equal to d by dt of mv square. Now, the kinetic energy with respect to time function I am differentiating. So same this also with respect to time function. Now what I am doing simply I did mv. Actually here m I kept constant, v I differentiated. The moment I differentiate mv square, we know the formula of differentiation. D by dx of x square differentiation if you do, the formula is 2 into x power of 2 minus 1, right? Same way, here v square I am going to write as 2 into v 2 into v power of 2 minus 1. So 2 minus 1 will become 1. Here I have the 2 and already I have expression 1 by 2. This 2 and that 2 get cancelled. I have mv is left. Then again from where dv by dt has come? Again this v also differentiable. V square I differentiated. Then who will do the differentiation of v? I did that. That is dv by dt. So mv into dv by dt has come. Now, dV by dt, what I'm doing here, little a small change I'm doing dV by dt is nothing but gives acceleration. M into acceleration, force in it gives us force. So force into V. This force into V comes from where change in the kinetic energy with respect to time. I got force into V, which also shows Newton's second law of motion. Okay, so V I can write as in terms of change in the displacement with respect to time, that is dx by dt. So dk equal to f into dx. What happened? How did I write dt get cancelled? Dk equal to f into dx I am having. Now we are discussing the topic. We know that that is work energy theorem by variable force, means force keep on changing. Force keep on changing, right? How if the force changes, the displacement also maybe changes, right? So now you see here, I'm using integration. The For the variable force, there is a variable displacement. The displacement has xi2, initial position of an object to final position of an object. That is, I'm applying the integration with the limits. This is, we say it is definite integral. What is this? Definite integral. So ki to kf, initial kinetic energy to final kinetic energy, I am applying. Tk equal to, same here also definite integral, initial position to final position I am applying, f into dx. That if I'll write where k and kf are initial kinetic energies and final kinetic energies with corresponding to initial displacement and final displacement. Now I can write after differential integration of dx gives us x. In the x, if I'll substitute the limits, final limit minus initial limit I have to substitute. Therefore, that gives kf minus ki equal to integration of xi to xf, f into dx I can write. Further, since f into dx, this is since due to the variable force, right? There is a displacement also changes. So this I can write completely as a work done w. F dot s no, nothing but f dot dx is also work. So it is happen xi to xf initial to final position. So that gives us work done. I can write change in kinetic energy equal to work done. It is work energy theorem for variable force beta. Work energy theorem for variable force. This is by using the differentiation and integration method, we will use it. Okay. Now, this is all about the work energy theorem. Next class, we'll discuss potential energy.